Hello, I'm Shin Young Lee, and today I'm going to introduce you about CRISPRs. So, what is a CRISPR?
CRISPR's here. Crisp.
CRISPR stands for Clustered Regular Interspaced Short Palindromic Repeats. Now you'll get why scientists just call it CRISPRs, right? CRISPR is a scissor of DNA.
Scissors.
Now let's take a practical example for E. coli and bacteriophage. Now, first, bacteriophage inserts its viral DNA into the cell membrane to duplicate more bacteriophage, which can kill the bacterium. But in the CRISPR locus, the bacterium already has the same information with viral DNA in spacer DNA. So they transcribe this DNA into RNA and forms a CRISPR RNA. And for Cas genes, they transcribe and translate protein and they make Cas protein. Now Cas protein and CRISPR RNA bonds together to form a complex and they attaches to viral DNA, and if the RNA and DNA's information matches, it breaks up the DNA. Scientists Jennifer Doudna and Emmanuel Charpentier discovered this phenomenon while studying Streptococcus pyogenes. Now, this bacterium do use Cas9 protein and CRISPR RNA, but they also use tracer RNA, which holds the CRISPR RNA in place. So what they did is they merged these two RNAs and named it tracer RNA and CRISPR RNA chimera, or guide RNA. So how this works is first heliase breaks up the bond and guide RNA sees if it matches the genetic information, and if it matches, the nuclease, which is an enzyme and depicted as scissors, breaks up the bond. So what if the bond breaks? Well, the DNA attaches together. So let's say a bond is broken up by Cas9 protein and guide RNA. Then the DNA either adjusts the broken part by making a little bit of change or mutation, or it gets repaired with the additional genetic information, so it can be used to cure diseases. Now let's see how it works in DNA. First, the heliase, the enzyme, breaks up the double strand. And then the guide RNA sees if it matches the genetic information. And if it matches, the nuclease breaks up the bond like this. So what happens to the broken DNA? Well, if there's an additional genetic information floating inside it, then the DNA adapts it. And then to adjust it, the DNA adds some more nuclear information like this.